So we are now looking at algebraic operations with vectors. So here we have 2 points. We have the point A and B. So A is the point 4, 7, so that's this point here. B is the point negative 4, 3. So if you notice here, A, B, it's going from A to B. So A is the tail, right? A is where we started, and B is the tip. So if we wanted to write this vector in its component form, we can do it 2 ways. Well, one way, we can do it like we did a couple minutes ago, where we kind of make this right triangle. And we look to see how we move. So remember, left or right first, because that's our x-coordinate of our component form. So on this one, we went 1, 2, 3, 4, 5, 6, 7, 8. We went left 8. And we went 1, 2, 3, 4 down. So my component form is negative 8, negative 4. Now we can also think of it like this, where if I didn't have a graph and I wanted to find the component form, basically it's kind of like we're doing the slope formula, except we are just, this is the we subtract our x coordinates and then subtract our y coordinates. So if I was doing that with these points up here, so let's say I didn't have a graph. So if I have the point 4, 7 and negative 4, 3, I'm going to do the tip, or where I land, I'm doing that one first. So I'm going to have my y minus y, so I have negative 4 minus 4, and my y's would be 3 minus 7. So negative 4 minus 4 is a negative 8, and 3 minus 7 is a negative 4. And notice I get the same as if I looked at it on the graph. Okay, and we can think of that here as the change in x and the change in y. So kind of like the slope formula, but we're not dividing these numbers. We're just subtracting the x's, subtracting the y's. All right, so on A here, we want to find A, B in component form. So I graphed A, B over here. So A was negative 8, 3. That's this point here. B is negative 2, negative 5. Whoops, sorry. So I, putting my arrow at B, because that's where I'm ending, because I'm finding A, B. If it was B, A, then I would be putting my arrow here. Go outside. Okay, so if I want this in component form, I can do it from the graph, or I'm just going to do it from my points here. So AB means B is my second point, right? So I have negative 2 minus a negative 8, and my y's would be negative 5 minus 3. So negative 2 minus a negative 8, I'm going to add those together. So we do get 6. Negative 5 minus 3 would be a negative 8. So that's my vector in component form. Now remember, I could move this anywhere I wanted to, as long as I went 6 to the right and down 8. No matter what, I have this same vector. I don't have to start it at the point that I was given in the beginning. All right, so now B, I want to find AB. So remember, that's the magnitude when it has those absolute value, and that is the square root of both of these things squared. So if I had 6 squared plus a negative 8 squared. So 6 squared is 36 plus negative 8 squared is 64. So if I add those together, we get 100, and the square root of that is 10. So the magnitude, or the length of this vector, is 10. All right. So on number 3 here, we want to perform the following operations both graphically and algebraically. So we're doing it both ways. So we're doing v minus 2u. Which way do we want to do it first? Let's do it algebraically first. So I have v minus 2u, and I want this to stay in component form. So v, I'm doing v first. So my x is negative 3 minus 2 times whatever u is. So I have a negative 5 here, comma, and then I'll do this in a different color. All right, so my y's, v, so I have negative 6 minus 2 times whatever the u is, which was 2. All right, so this would be through negative 3 plus 10, which is going to give me a 7. And then my y coordinate here would be negative 6 minus 4, which would be a negative 10. All right, that should be what my resultant vector is. So let's see if it actually works that way. So we're doing V. Doesn't matter where we start. Remember, we do not have to start at 0, 0. So I'm going to do V. I'm going to do it in this pink color here, purple, whatever color you want to call it. So V says start it somewhere, and then I'm going to go 3 to the left and down 6. Let's just say I started here. Now I'm going to start over here. Okay, so here's where I'm going to start. This is my tail, right? So I'm going to do 3 to the right, 1, 2, 3, and down 6. 1, 2, 3, 4, 5, 6. Okay, so there's V. So there's my vector V. And then I need to do a minus 2U. So U normally goes, did I mess this up? I think so. This is going to go off the graph, so I'm going to take that off. Let's say I'm going to start over here again. All right, so I'm going to go 3 to the left. 1, 2, 3. 1, 2, 3, 4, 5, 6. Oh. That did not have to happen that way, it just did. Okay, so there's V. Remember, you can start anywhere. Okay, U normally says left 5 up 2. But because I'm doing a minus, I'm going to go right 5 and down 2. So 1, 2, 3, 4, 5, 1, 2. Okay, so that's U. But I got to do minus 2U, so I got to do this again. So 1, 2, 3, 4, 5, 1, 2. All right. So this was a U, and this was a U. So my resultant vector, remember, is from the tail where I started to the tip where I ended. Sorry. All right. So let's see. What would our resultant vector, if we wrote it in component form, we think it's supposed to be 7, negative 10. So let's see if it is. 7 goes to the right, 7. So 1, 2, 3, 4, 5, 6, 7. So there's 7 and 10 down. Is that going to work? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at us. So we went 7 to the right and 10 down. So this, there it is in both forms. So kind of sometimes it might be easier if we did this